Okay, yeah, more or less in time. Today we will start with an interesting topic. I hope that the course, as I told you, we are at most at at the end of the course. We will hold today until 8 o'clock. Okay. And I hope next week, in any case, I will redo a lecture because I missed a lecture last week. With these two lectures, we will see together this interesting model or control for an interesting model, which is a Lotka-Volterra model, which basically is a competition model, which is used for not only for competition systems, economical systems, or in general, I would like to say population dynamics, biological systems. But in any case, mathematically is itself extremely interesting because it's non-linear system. Until now, I didn't tell you about nonlinear systems. I will really sketch a little bit the meaning, the characteristics of, even though to start speaking about nonlinear system with the Lotka-Volterra is really hard because it's an extremely complex model. But I will try to simplify as I can. Okay, the lecture which you can find in my study looks like, let me open something like that. It's written lecture 3, as I already clarified the meaning, because because of the structure of our course. As I told you, the course is organized, is topic or the topics oriented. It means I have to select different topics. The reason is one of the reasons, not the unique one, is that your background is different. I mean, we have here in the course an heterogeneity of the background, students from everywhere. Look here, I don't know if it's the last version. It could be that we have some LaTeX refuse errors in this sense, but no problems in this sense. I will indicate as last time. I don't know. I told you about LaTeX, remember? LaTeX is a way to write a document. Sometimes it's not so so easy to realize the slides because using the software, because is in the program, no? Is in the language to produce such kind of presentation, which nevertheless, in my opinion, could be very well stated with LaTeX, because we will see also today we have many equations. Look here, competitive Lotka-Volterra equations. Sometimes competitive is omitted because Lotka-Volterra itself is in a competition, but here the idea is to emphasize these characteristics. Yeah, really a few things, because I would like to switch relative, I don't know, soon to an interesting application, which is basically the COVID application. I will show you now the basic structure, which can be used in any kind of, again, competition system, economical, biological, and population dynamics. But the idea is to introduce also something related to control. Okay, look, in the middle, we have these two equations. Let me summarize a little bit this information. This slide is full for information, but we have seen during the semester that we are oriented to equations. At the beginning, I started with this identification. So I hope that next week I will tell you about this parametric identification. Why that? Because in this equation, we will see 4 parameters: alpha, beta, gamma, delta, which must be known in order to control somehow the system. Must be known perfectly? No. We're not necessary to know perfectly the parameter, but somehow we have to put some values. Look, coming back to this slide, we can see two equations. About the differential equations, I already told you last time. You remember, I told you in the context of this bank system. The bank system, or at least what I presented last time, consists of two equations, as this one, but these two equations are linear equations. Now, today we introduce another concept, non-linear equation. Also, last time I didn't insist on the definition of linear. Now, today, because I am generating a difference, I try to explain, even though quickly, the concept of linear, which we have seen last time, and here the concept of non-linear, but really quickly, because in some university there is course is dedicated to non-linear system, not only one, more than one course. Linear means that the superposition principle, I don't know if you heard about the superposition principle, holds. What is the meaning? The meaning is, if I have two causes, I can consider the two causes together and to observe the effect or effects. But in the meantime, I can consider one cause and to see the effect of this one, the first cause, let me say. No? Then to consider separately the second cause and to observe the second effect. And the sum of the two effects equals exactly the effect which I have if I consider two causes together. This is a little bit, I would like to say, in a way, colloquially, but not only colloquially, as in physics, is the superposition principle. We have two causes and two effects. These two effects can be considered separately, but we consider together, they represent basically the effect of the two causes together. I don't know if can be understood. Let me see if I can find an example. In order to understand a little bit better, let me consider this phenomenon. To breathe. Assuming that I am breathing here, I'm consuming the U2, no? I am here for 1 hour. If this phenomenon is linear in the sense, you can consider in the same way two persons, we are inside, which is breathing for half hour, and they consume the same oxygen as me. Let me say, or better to say, is not exactly if I, better to say, split in this sense, this phenomenon in half hour and half hour, this consumer is the same. It's not, I don't know if it's a good example to understand. I mean, it's splittable. I can split somehow the causes, if I have two causes. And the effect in the same way, I can split and I can reconstruct, considering both together. I don't know if this is a good example. Yeah, in nonlinear system, this is not valid. I cannot say that I can split the causes with the effects, roughly speaking. Look at this example here. If you remember the example, these equations, the example last time with respect to this, in the mathematical sense, is totally different, because here we have the product between two states. Remember the concept of states I told you last time. States represent the energy of the system. And last time we have seen the liability, we have seen the assets, and mathematically the states are characterized by the derivative. I can recognize the state directly if this variable appears in the model as a derivative. Here, for instance, alpha is not a state, beta is not a state, delta, gamma, they are not state because we don't have derivative of them. X and Y, their state, reflect somehow the energy. But we can see that we have the product between the two states. Last time, we didn't have in the model the product between linearity assets. If you come back to the slide, we can see that. In the model, we have the linear combination, probably from math, you remember this concept from gymnasium, from high school, a linear combination of functions, of elements. And this concept of the linear combination reflects exactly this linearity. Here, the product between two states says, we can also mathematically demonstrate, that we cannot split possible causes with possible effects. This makes a very, very, how possible to say, a big difference in between. First of all, the representation using matrix and vectors is not so always suitable, or better to say, cannot really directly applied in terms of eigenvalues. Do you remember last time I told you the eigenvalue of the matrix? But I don't want to go so in depth in this course. Let me go ahead with this structure here. Non-linear, because mathematically having a product. I try to intuitively, colloquially, and explain the non-linearity. What is X, first of all? X represents the number of prey, or preys, plural, if you want. Prey, let me say prey. For instance, rabbits. Y represents the number of predators, or predator, foxes. We can see that here the energy is, as last time, represented in a pseudo system, in a pseudo way. Why that? Because it's difficult to think about as the number of rabbits or the number of foxes represent the energy. But if you think on our concept of energy, which is not necessarily connected with kinetic, potential, electromagnetic, electrostatic, but it's something, an entity is something which I can store. Of course, in this sense, I can count the number of rabbits. I can say in this room we have 100 rabbits. Tomorrow will be, I don't know how many. If I put some foxes, this means these two populations will be in this room. They establish a competition, let me say so, and I don't know how many rabbits will survive. In this sense, we have a dynamics. And this equation, these equations, when we have two equations, we will see is state somehow some interesting equilibrium points between the two populations. Look at this comment here. As I told you, the derivatives represent always changes, therefore represent the energy. Because for us, the energy is important, it's characterized by the changes. The energy itself does not have a meaning. The energy is always something with respect, is an entity which is measured with respect to a reference. I mean, this point, this object here, at potential energy with respect to the table, 0. But if I consider the potential energy with respect to the floor, it's not 0. I don't have any changes. We can see that in this case, we have any changes, we transform. Please think about the concept of the transform. Now, means here, look at this. The variation of the number of rabbits equals this expression here. Now, I try to analyze in an easy way. Assuming that y is 0. In this room, we have just rabbits, no foxes. Excuse me for the trivialization, probably for students who is in the biological system, you already, they already know this, but I try to explain for everybody, as I must be for everybody. Y is 0. This means in accordance with the definition, the predators, the foxes are zero. This means, in accordance to this model, I don't know if you remember also last time, I told you a little bit, in accordance to this model, the rabbits will grow with this law, the derivative of x with respect to the time equals alpha multiply x of t. I don't know if you remember x of t, the solution of this equation here. Let me speed up showing you the solution. You remember it's an exponential function. I will, the x of t, the rabbits, the number of rabbits will grow up. Let me see if I have it here. I hope you can speed up a little bit. Yeah, I have it right. I will upload. No. Exponentially. Too easy? Should I speed up a little bit? No, it's okay. No? Because I know that not everybody. Anyway, I think not all students are familiar with differential equations, even though this is extremely easy. Probably you have seen in math, I don't know, in gymnasium. Excuse me again for. Okay, now probably. Yeah. Why does it work? Oh, no. The system is exactly what I told you. I don't want to see something more. Y equals 0 means no foxes. The first equation collapses in this one. Let me say that at time 0, when I start to observe, to simulate, to observe, eventually to control the system, we have that the number of rabbits equals x0, 100. You can say whatever you want. X0 is 100. I don't know if you remember how we can solve the differential equation. I don't have time to explain. If you know, okay. If you don't know, it doesn't matter because MATLAB will help us. But anyway, you can eventually see again how I can calculate x of t with these calculations. But very important to be able to simulate with MATLAB and the solution. This means x of t solution is in a mathematical word. For us means how change the number of rabbits over time. This sentence will be translated by mathematicians. What is the solution? Please pay attention. This is extremely important in our field, in complementary, to understand the language of a mathematician or the language of mathematicians and our language, which want to apply this. The mathematician says, what is the solution of this problem? And the mathematician using this knowledge, I don't have time to tell you this, but you can look at this slide. They calculate for us this. We are not good mathematicians, but we are good in MATLAB simulating. We can, as last time, to implement this, because this is not different with respect to reliability. It's not much different. You remember also my capital in the bank will increase exponentially. It's really the strongness of this course with this knowledge. Of course, if we know mathematics a little bit better, we can do something more. But believe me, here it's not in the course of mathematics, but look, if you want to look at the solution, we can obtain mathematically this expression of t, which says to us how change the number of rabbits over time, starting from x0, because if you remember in math, at t equals 0, exponential, this is exponential function. E is the exponential function. Up to 0 is 1. This means starting from x0, 100. How grew up the rabbits? Why E represents the exponential function? I don't know if you remember very shortly, because in the linear equation, the eigenfunction is an exponential function. I don't know if you remember, because the derivative of the exponential function equals itself, or almost itself. Here we are looking for in a function. We can see that the derivative of x is alpha multiplied again x. This recall as, if you remember in gymnasium, our exponential function, which can solve in terms of mathematical language this problem here. What is x of t? The problem is, what is x of t? What is the solution? In our complementary course, how change the number of rabbits in the room if I don't have rabbits? You can see here how the mathematicians work, and at the end they say to us, this is the x of t. We can see that over time, what is the meaning of time? We have seen last time, everything. You can consider 1 day, 2 day, 3 day. Really, we don't have this continuous function, but in a stepwise continuous function. Because, of course, we can also observe each nanosecond in picoseconds. But of course, as I told you, I will come back tomorrow. I will come back, I don't know when, to look how many rabbits we have in the room. But you can say to me, but please pay attention. How can survive here infinite rabbits? We can see here from this equation, it seems to be that in this room, I don't know when, but we will survive a number unlimited of rabbits. It's clear it's in the limit of the model. This model does not consider any limitation of room, any limitation of food. We have a more complex Lotka-Volterra models, in which we can include these limitations. This can be done, if you want, with the projects. We did for Fisher dynamics, we did in different contests. Of course, here in this room cannot survive without food, without considering the limitation of the room, infinite number of rabbits. But this means this model could be validated considering infinite foods, infinite room in this space, of course. But if we consider more complex equations, we can consider also this limitation. Of course, the equation is extremely complex. Yeah, please ask me. Now we will consider foxes, and then all together, and then we will see how we can control. But the control which I will consider is in COVID, because it's, in my opinion, it is interesting and is a simplification of this. It could be understood. But in the project, we can also consider really more complex equations, which we can consider limitation foods. We can consider limitation room. Because here, it's clear it's not realistic thing. Anyway, if you don't have limitation, it works. But very often in an ecosystem, we have also limitation in the room. I am not expert. You are expert better than me. I already told you last time, we did an interesting project in Fisher, in an ecosystem in the lake. And anyway, I assisted the student, but I'm not expert in such. Look at this now. What happens in the second dynamics? Basically, now, in order to understand, I try to consider the two dynamics in a separate way. If x is equal to 0, this means no prey, no rabbits. What happens for the foxes? The equation is this one. Why that? Because these original equations, and in particular, this equation here collapses if I put x equals 0, no rabbits, in the variation of the number of foxes equals minus gamma the number of foxes. Again, alpha, beta, delta, gamma, as is written in the slide, are positive in this model, are positive. This equation here had a similar solution as the equation with respect to x. always the exponential function, because the exponential function in linear system represents the exponential function represent the eigenfunction. What is the meaning of the eigenfunction? The derivative of the exponential function is something again related to the exponential function. I don't know if you remember this rule in math. No? The derivative of exponential function up to t is again itself. The derivative of exponential function up to 2t is 2 times exponential function up to 2t. I don't know if you remember this rule. This means that the mathematician will demonstrate that the solution of this, the solution for us means the number of Foxes over time, is this one. If you are not able to calculate analytically, it's not a problem in this course. But for engineers, it's easy to do that. For the rest, it's not. For the rest of the group, it's not so important, because we will see with symbolic. But this function here, or that this change over time of the number of Foxes, is characterized by minus gamma t. Gamma is positive. Before, do you remember, the solution was characterized by exponential function up to alpha t, alpha positive. Therefore, we have something which is increasing over time. Here, starting from y0. Why that starting from y0? Because at t equals 0 is exactly the time in which we start to control, to observe what happens. We have the number of Foxes y0. I don't know, 3 Foxes. Doesn't matter how much. Starting from 3 Foxes, we can see that exponentially is going to 0. The Foxes will extinguish if I don't have rabbits, assuming that they don't have all the kind of foods. No? This is also another assumption. We have another assumption too. We didn't distinguish in particular in the dynamics of the rabbits, male and female. Because how is it possible to increase if we have just female? At least it's difficult to demonstrate. This means it's the project which we have, or the system, is quite abstract. This means we can distinguish more sections, male, female. You understand what I mean? And the system will be extremely complex, because if you remain just one group, of course, you will distinguish. We can see at the end the work very interesting, but in the context of COVID, in which we consider a lot of sections and a lot of different populations. This really is still complex with this abstract model, in which no limitation room, no limitation food, no limitation male, female, and so on. These equations here, believe me, don't have an analytical solution if I consider together. We don't have an analytical solution. Now, what happens together? This is really complex. Let me come back to the presentation until 8 o'clock, no? Clear. Anyway, if you cannot stay, you can look at the YouTube, no? But I hope that will be not boring, but it's not the problem. Probably you have a bus and so on. Here, you don't need to read exactly here, because I already told you everything, but please, just colloquially, what happens if I consider this equation, but including this interaction? Please pay attention. X multiply y states the nonlinearity of the equation, because X is the population, y is the population. Nonlinear means products between the states, means that the state appears squared. I don't have time really to insist on linearity and non-linearity differences, but I would like to tell you this interesting semiotic meaning. You know the word semiotic? Looking over, semiotic means that the symbology reflects the meaning. The product reflects the meaning that these two populations, they have contact. I mean, at the beginning, I told you x equals 0. But I can say we have a room in which I separate with a wall rabbits and foxes. If they don't have contact, the equation does not change. It's exactly what I told you before. It's not necessary to say x equals 0. If I say, please pay attention, in this room, I build in the wall. From one side, I put rabbits. From one side, I put foxes. The dynamics which I told you before, I mean, the same. Foxes will extinguish and rabbit will increase because they don't have contact. This means x multiplied y is 0. Even though x is not 0, y is not 0. I don't know if it's clear the meaning. Please pay attention. This is something interesting in the math. Because in math, we understood that the product is 0, and the product is 0, if and only if one of both are 0. If x is 0, the product is 0. Or if y is 0, both is 0. Here, in the context of the model, if I say that they don't have contact, x multiply y, it's 0, even though x is not 0, even though y is not 0. The model, we have to understand what I intend. Why the product represents the contact? Because also symbolically, or also semiotically, x is close to y. X plus y, they're not close, but x multiply y, they are close. Think about this semiotic concept. You know the word semiotic? Look in Google. You know. Why you know? I already told you about semiotic. No.
Like that it's symbolic.
It's symbolic.
That's where the thing looks.
Because in the symbol, we have the meaning. No? This is very interesting in math. A product represents the contact. But the product is represented x close to y, in contact. In fact, in the modern math, we can put very often dot, because we emphasize the contact with x and y. Okay, I don't have time to insist on this, but I would like to insist on the meaning of this equation. Look, increasing x, I go up with x. I will increase, nevertheless, an element here, this product here, which reduces x itself, really colloquially, no? Because to analyze this is extremely difficult. This means it's not totally valid that if I have a contact that x, of course, valid. I mean, if I have a contact, x will not necessarily increase to infinity. Why that? Because increasing x, I will increase also this part here with minus. This means there is a point in which x could be that will not increase. Could be, but it's unclear. You understand? It's unclear. Because if x increase also this part here, but with this minus, we reduce the rate of change. Please pay attention. The derivative is what we need. The derivative is everything. The derivative reflects the state. The derivative reflects the changes. This means increasing x is not clear what the derivative will do. Could increase, but it could be that not indefinitely, because this element on the right, we have this minus here. What happens? Excuse me here, no? What happens for what? It's the same situation. Look, when we have the contact, we can see that the contact appears in both equations. This is also intuitively understandable, because if you have a contact, they should influence both dynamics. Look again here. I try colloquially to explain the dynamics, which is extremely complex. You know the word chaotic? Yeah. We will see that this kind of systems can become chaotic. Why it was extremely complex to control the COVID? Because the COVID, we will see today, is a chaotic system. But we work a lot in this course. We produce also some publications with some students to control the COVID. It's this equation with a small modification. I show you, this is, in my opinion, extremely interesting. Let me show here. We can see that the contact, it's in both equations, we can understand, because if they're in contact, this means the dynamics are in contact. This means the derivative is in contact, it's connected. Of course, we can see that in one case we have a minus here, in one case we have a plus. The reason is, the reason, possible explanation or validation, that's increasing x, we can understand that the trend of the number of foxes will increase because they have more food, or potentially more food, if we don't have a barrier, of course. This means if the contribution is negative, let me say to limit x, here the contribution is positive to increase y. The reason is a little bit inside. Y here is negative. It's negative because increasing x will increase also y. We can see from here. This means we will think about oscillations. I mean, the meaning of this minus here is connected with this dynamic here. Because increasing x, we can assume that we increase also y. There is a point in which we can think that we have an oscillation between these two dynamics. But increasing y, if you look again on this equation here, we will decrease x. Okay, just colloquially, we will see now mathematically. Allow me a little bit to be boring now. The nonlinear systems are characterized by equilibrium points. I didn't do last time this concept here because in linear system we have just an equilibrium point 0, 0, or 0, 0. Depends on how many states we have. We have last time 2 states, the equilibrium point and the ability 0, asset 0. This means if I don't have money in the bank, if the assets in the bank is 0, no movement in the economy. Trivial. Of course, if the system is non-linear, the economical system can be also non-linear. Last time we have seen just an economical system linear to start. The system here is not linear. And the nonlinear systems are characterized by equilibrium points, which can be stable, cannot be stable. The equilibrium points. Last time I characterized the linear system saying that my system was not stable. I don't remember. The liability will increase, otherwise I don't put money in the bank. I didn't tell you about the stability in debt, but a little bit. Look at here. What is the definition of equilibrium points? The equilibrium point is defined mathematically, also intuitively, the point in which the derivative will not change, roughly speaking. The derivative is 0 means the rabbits does not change, the number of x is the number of rabbits. We have to find condition, let me say conditions in general, in which the number of rabbits does not change. This could be an equilibrium point for the rabbits, but the same way, together, because we have a system. Remember in Gymnasium we learn the symbol means together. Together at an equilibrium point of the foxes. I mean, if I'm able to find in my ecosystem a number of rabbits, a number of foxes, in which the system remains at this number, that is an equilibrium point, which could be also suitable because the idea is that foxes and rabbits, they are in equilibrium. I don't want to any species will be extinguished. Typically, is this the idea, not to preserve the number of rabbits and the number of foxes. Now, if I put this condition in the equations, we have a nonlinear but algebraic equation, which in this case can be solved. I don't know if you remember in high school, even though I have an algebraic system, not necessarily solvable if the algebraic system is nonlinear. this case is solvable. I mean, if I have here arcotangent, the sinus of arcotangent, be that I cannot analytically solve. I don't know if you remember this. I don't know. But anyway, in this case, we can solve. We can find x and y as a function of alpha, beta, delta, gamma. This must be known to identify this. I hope that will tell you next week. Two equilibrium points. I hope no mistakes in equilibrium. Let me see. So sometimes I have an old version of the, I hope this is correct. But anyway, x0, y0 is intuitive, no? From here. If x equals 0, look at this. If I put in evidence here x, let me see if I have also this for you. No, I don't have, but it's easy to see. Y x equals 0 and y equals 0 are equilibrium point. If you put in evidence x from this both, I have x which multiply alpha minus beta which multiply y parentheses. I don't know if it's visible. Put in evidence, you understand? Put in evidence x from here to here. We have x parenthesis alpha minus beta y parentheses. This means x equals 0, satisfy the equation here. But also here, if I put in evidence y, the same. We have a y which multiply delta, parenthesis, delta x minus gamma. Y equals 0 is also a solution. But we have also another solution. We can see from here that we have that, if you want that, x equal alpha divided beta from here. Should I do mathematically? No, it's easy. Should I do? We can see, no? And the other one from this here is y equal gamma delta divided gamma. Gamma divided delta, excuse me. Gamma divided delta. Yeah, exactly. It's the second solution. This means if I don't have, what is the meaning? If I don't have rabbits, if I don't have, what is the meaning here? If I don't have in this room or in a room rabbits, and if I don't have foxes, no changes. Trick, no changes. Here's more interesting because it seems to be that for a given ecosystem characterized by alpha, beta, gamma, delta, this is really interesting in what we did in the past. This must be identified. That's characterize really the system because this alpha, beta, gamma, delta have a biological meaning. I'm not expert, but you probably understand better than me. And this condition, we have something interesting because it seems that the number of rabbits and the number of foxes, they can together survive. Survive in the sense they exist without distinction. Because no changes for X, no changes for Y, no changes for rabbits, no changes for foxes. This is very often what we desire, not that as an ecosystem remains in equilibrium. I don't want that the foxes will extinguish all the rabbits. No? This is a typical challenge in biology. I'm not a biologist, but why not? No? This is extremely interesting, this point. The control, what we can do, is to maintain these equilibrium points. This was the work of Fisher and so on. What we can do, yeah, it's not explicit given, but we can put food, we can put, we can change the room in order that we can see really mathematically with the simulation that the foxing will be not so aggressive. And we can really mathematically see this. Of course, we have to conceive a little bit the project, but really we can see the aggressivity. We will see a little bit, I don't know, because the system which I will present later is the COVID is a little bit easy, but not so easy. But also the virus, the goal of the virus is not to destroy the humanity. The goal of the virus is to disseminate itself, to go to conquer, but it's not to destroy the humanity. During time, will be weak and weak in order to It's interesting, this aspect here, but I'm not virologist. I don't want to say something mathematically. I speak mathematically. We can see. But if really then reflect biologically, but could be mutation, no? The virus will mutate it. But weaken, because the goal is to disseminate itself, not destroy the humanity. But anyway, this mathematically we can see. But if this is reflected also biologically, I'm not sure, but it makes a little bit sense. Mutation, no? We say, they change to survive. This is always natural. No? And also, the human, they we say, it's an interesting word, I don't know in English, if you know, now I don't have a mind. When I find okay, this I told you this. Yeah, we have here an interesting theory, the Lyapunov theory, the Mathematica. Lyapunov, probably you know, Lyapunov was professor in Kharkov in Ukraine. He came from St. Petersburg, and it was professor in Kharkov. And it was one of the more important mathematicians in the last century. And he formulated interesting results in the context of nonlinear system. I have also the book of Lyapunov, because my wife came from Kharkov. He bring me the book from Lyapunov. I have the original book. Here we have one theorem of him, the Lyapunov linearization method, in which basically it states some criteria in order to judge if an equilibrium point is stable or not stable, but in the context of an neighborhood, basically close to this point. We say here that if we calculate the Jacobian matrix of an equilibrium point, I don't know if you remember the concept of the Jacobian matrix, the derivative, that we will see now in practical sense. And then he formulates these two sentences. No? Assuming that x0 in our case equals 0. No? 0 could be everything. Could be 0, could be this here. 0 is the goal. No? The mathematicians think about 0 our goal, our element, not necessarily 0, 0. In fact, at the beginning, I wrote for you xz, an equilibrium point, which is calculated using this definition, if you want. And then he formulated these two sentences. X equals 0, by x0, if you want, is an exponentially stable equilibrium point of a nonlinear system if all eigenvalues of the Jacobian matrix have negative real parts. Jacobian is the derivative. Let me tell you, in accordance with your knowledge in high school, the Taylor approximation. Taylor is known, no? Around this equilibrium point. It's a little bit more complicated because we don't have just a variable, we have two variables. This means we are speaking about matrices. And then the second sentence say that is unstable if the Jacobian matrix at least one eigenvalue with a positive real part. I don't know if you remember eigenvalue of a matrix, probably no. You don't remember. I go through really fast, and then we will see the COVID. What about the Jacobian matrix? The Jacobian matrix is the matrix of the partial derivative of the system. It's easy to do the example with which I told you until now than to explain the definition. Calculate it at the equilibrium point. Look at this. Yeah, it could be that we have an error, but if you have an error, I will be able to correct. This is the system. What is the general Jacobian matrix? Here, at this position here, I will put the derivative with respect to x of this expression which we have here. This means alpha minus beta multiplied y, the derivative with respect to x. Here we are in the dynamics of x. this part here is a function of x and a function of y. At this position here, we'll put the derivative of this expression here with respect to x. Did you agree? Is this? No? Because y is considered as a constant. Therefore, I told you partial derivative. What is here? Is the derivative of the same expression with respect to y. Therefore, remain just beta multiply x. Because the derivative of this expression with respect to y, this is 0, and this is minus beta multiply x. If I do the same here, this means this element here is basically the derivative of this expression here with respect to x, which is delta multiply y, and this here is the derivative of this expression here with respect to y. Clear? Okay, so define basically the matrix of the partial derivative. Now, let me check what happens at the first equilibrium point in accordance with the Lyapunov theory. If you put 0, 0 here, this expression here will collapse to this one. I hope no mistakes. Let me say, no, I don't see mistakes. Alpha 0, 0 minus gamma. Look here. Alpha, if y equals 0, if x equals 0, 0, if y equals 0, 0, and you have a gamma if x equals 0. This is the matrix. Look, the eigenvalues is alpha minus gamma. I don't know if you know the eigenvalue. If you don't know, it doesn't matter. Believe me, I don't have time to clarify what an eigenvalue is. But in accordance with the Lyapunov theorem, we can see that we have an eigenvalue is positive. This means, even though I have a 0, 0, mathematically, it seems that something grew up. What? The foxes, the rabbits. Seems strange. Isn't a little bit in contradiction between a mathematical model and the reality? Because if I don't have foxes, if I don't have rabbits, why is growing up? Growing up because if you think about the Taylor idea, I don't know if you remember the concept of the derivative. The concept of the derivative is related to the limits. Close to 0, close to 0. I don't know if you remember this a little bit. Like Buru. This means mathematically, if you're not exactly a 0 mathematically, the rabbit will grow up. But of course, again, a contradiction, because if I have a half rabbit, if I have 1 divided 10 rabbits, what is the meaning? No meaning. In fact, if we discretize the system, I don't remember last time I told you a discrete system in the context of economical system, such kind of contradiction will disappear, but remain on this. In order to show you that we have to be careful when we are working with the model. Because one thing is the mathematical model, one thing is also the wording of the mathematician. Solution for us means how change the rabbit or the foxes. Stable, mathematically, Lyapunov calculate state interesting results. But for us, it's not the meaning. I mean, half rabbits. For us, that doesn't mean anything. Half rabbits doesn't have a kind no dynamics because half rabbit means the dead rabbit. This I don't have time to go in depth, but with the project we can do very well because I will also next week I will present a little bit the system in discrete form because the system is discrete. You have 1 rabbit, 2 rabbits, 3 rabbits, and not half rabbit or 1 divided 1,000 rabbits, as Lyapunov at this moment assumed. I don't know. You have to really be careful in this sense. And then again, male, female at this moment is don't care about that. It's extremely complex. But in the project we can do. Did you see in Loifana Facette what we have this week? You did see? We have an article from Studio Mai. We received the best paper award last time I told you, and they wrote for us an article on PSO, particle swarm optimization method, from this course. But of course, he worked after the course. Yeah, here we have some mathematical issues or aspects to calculate the eigenvalue. Forget this. I can do the same. I can do the same for the point. Do you remember gamma, delta, alpha, beta? It seems to be that should be inverted because alpha, beta was for x and gamma, delta was for y. Please pay attention. I will correct, but it's clear the meaning. If you do this, you don't have to do, you will calculate something interesting. Lambda 1 and lambda 2 will be complex. If they're complex, you remember Gauss theorem, conjugate. This, if you remember in the system theory, means oscillations. In the theorem of Lyapunov is not included in this case. No, because it states just stable or unstable. If we have all elements real part negative, is asymptotically static. The means going to zero. No? As they think about the forces. If one of them, as we have seen before, is positive, we have asymptotically unstable, go infinite. Mathematically, we speak mathematically. This is not the case which is considered. In fact, this case here, we can demonstrate is the case in which we have oscillations. Because complex eigenvalues in the differential equation, engineers know better than me, probably from the course which I held here in this university. Yeah, I would like to stop here and let me go in this half hour call. We have seen the first theorem of Lyapunov, extremely important, because the idea is to control very often the system in the equilibrium point. To do something, control means, now we introduce the concept of the control. For instance, here could be to put food, to maintain these two populations in this equilibrium point, or to catch some foxes or some rabbits. This could be defined. Let me now switch on the lateral camera and let me tell you about the COVID system, which is a Lotka-Volterra equation with a modification. As I told you, if we modify we have a many modification of the Lyapunov, also of the Lyapunov theory, but of the Lotka model to represent a really complex structure like limitation in the room, limitation foods. If you look Lotka-Volterra equations, you can find a lot of model which can represent really different system, but always in the context of competition or population dynamics, COVID also. Today, now we will start with the model, and I hope to introduce also the second theorem, one of the theorem of Lyapunov. Let me see. Yeah, found it. I hope it's not boring, no? The name Lyapunov was known, no? Lyapunov, mathematician. You know Lyapunov from Kharkov? Yeah. No, you didn't hear. But he is died 100 years ago. Okay. Yeah, I don't know if it's visible. This is always more or less, please pay attention, the equation which I showed you before. But without these two contributions, is exactly what I told you before, quickly. I don't know if you recognize. Without these two elements, it's the same. What represent these two elements? Inputs, food, or I can represent to catch some, I don't know, rabbits or foxes. It's something which externally can change the dynamics. Think about food. Look now, one of the the most, let me say, I don't know why it is not so clear, the image. Better? Yeah. Look at this equation here. I put here 3 equations, but the last one is extremely easy. The first and the second one are exactly, let me say, the first one in which I put alpha equals 0, not x, alpha equals 0. But the contact is there, no? You remember before I told you in a wall, what is in a wall? The wall is beta equals 0, x not 0, y not 0, beta equals 0 reflects the wall between x and y. I forgot to say why I told you about the Durban. X is not 0, y not 0, the wall, if I build the wall, beta equals 0, no contact. Here, between this equation, we have this alpha, which is the rate of change. Yeah, the rate of change, I don't remember, basically, the rate, the reproduction rate. Alpha is the reproduction rate of the rabbits, if you want. Here, I put alpha equals 0, in this dynamics here, in which we have an input. At this moment, we have an input. Now I clarify what is this input here. S of t represent the susceptible people. I mean, susceptible people is people which can be infected. Susceptible, understand what it is? No? Auf Deutsch wäre anfällig. Yeah.
So the rabbits, basically.
The rabbits reflects the rabbits. But why alpha equals 0? Because itself, we assume that the susceptible people cannot increase. It's an assumption. Because if in the society come people from in the town, come people from external, of course, this is a little bit, but it's not exactly what I intended, because this is an input. It's not an internal, I mean, this means that, yeah, that the population, in this sense, does not have a self rate increase factor. Of course, this is nevertheless an assumption. The product remains. Of course, this is an assumption. This means that S, the number of susceptible, remain constant in the sense itself, but not constant, because if we have the contact between I, which represent the infected with its dynamic, of course, we can see that the susceptible people will decrease because of this contact here. What is this this UV? This represents an input, and I consider the vaccination. I mean, including an input which is the vaccination in this case. In this sense, we can see that the susceptible people will, in this sense, will change. Let me see the second equation, and we will insist on the meaning. This equation here is exactly this equation here, no changes. Basically, the predator, which is the infected, does not change. Of course, here I didn't put any input. I didn't put any quarantine. Because otherwise, it could be a little bit more difficult, too easy to control, but more difficult to interpret. But anyway, we can consider also in the project of another input here. At this moment is exactly what I told you in the sense. What is this? R represent the recovered. Here, let me see a little bit the definition. S again is susceptible, people who can be infected. I is the infected people. R is the people who died or recovered. diet recovered is the same in this context. Assuming that the people who recovered cannot be infected, reinfected. This is an assumption. Otherwise, we have to consider another category, another dynamics, complex. The model, nevertheless, was used a lot of times mathematically. The name is this one. You can consider SIR in accordance with the nomenclature SIR, and then was if you look also in Wikipedia, I think this Kermack-McKendrick model was used also for different epidemics. And then REA, we can see infection rate. A is the remove rate of infected. We can see the unit. We have seen also in the bank, it is easy to determine the unit. This is infection rate is time up to -1. Also the remove rate of infected is 1 divided time. Of course, we have a lot of modification of this. For instance, this ESIR, this is a model with latency. This means the susceptible people is divided in 2 groups, nevertheless infected, but not visible. We can really realize extremely complicated models. I will show you in a publication of us, which really, I don't remember how many sections of the subpopulations. But this is, if you look now in Google, you see here, Kermack-McKendrick model or SIR is used. Nevertheless, it's usable because it's not so easy, nevertheless. Let me see if I forgot to say something about a possible interpretation. Of course, if I vaccinate, we can see that I contribute to a negative element of the derivative. This means I will decrease the number of susceptible people. I don't know, it's intuitive. Of course, the number of susceptible people, assuming that we realize an immunity. Now we will define the immunity mathematically. Let me see if I forgot to say something. But in any case, we are considering a society which is close because we don't have this alpha S. With this also a limitation in the sense. This means the model is validated. Let me say day per day, we cannot consider a long period because if you consider that the society will change because if you consider that today or tomorrow will born child, this means day per day can be used, assuming that between today and tomorrow we don't have many internal change of S. I told you before. We use this to predict and to rely to what is the idea? To calculate the number of people which must be basically vaccinated in order to guarantee, now we will see exactly, the immunity of the society. What is the immunity of the society? I will mathematically tell you now. Did you look at this Kermack-McKendrick model or SIR? I am sure there is in Wikipedia. Found it? Yeah, it is. It's used, but of course, must be used in accordance with the limitation which I have. If S does not change, this means we don't consider the children which increase S. Because when the children born, of course, they are not directly vaccinated. This means it's valid day per day. Meaning I put the initial value of S. This means today, what is S? We know from the journal, from the newspaper, how it is the estimation susceptible people, and then we will restart the simulation. We need the value of I. What is the infected people? At that time in COVID, we had day per day the number of infected and the number of susceptible. We have to restart with the simulation. We have to restart to calculate the vaccinated possible vaccination each day with a new initial value, because it's valid if S does not change itself, alpha equals 0. This means day per day. This is very important in our case. When is valid the model? Yeah.
Question. I don't really understand why the vaccination is only in the susceptible thing and not in the recovery. Because in my head at least, wouldn't the people who are vaccinated, well, yeah, but there's no input or like output of the vaccination there. Or is that, or at least I don't see it in the.
We don't have, because.
But what happens to the people that are vaccinated? Because technically they're also in the same category as the died and recovered, because they're not susceptible anymore, but they're just gone. Where do they go in the system?
Here in this model, we assume 3 categories. You're right. Why this dynamics is not connected with S is the question. There is another model which is connected with S. If you look in Wikipedia properly, you can find it. As I told you, I'm not so expecting. Let me think if I find a possible answer. Again, yeah, there is. We can. This could be a project for you.
Okay.
Yeah, because you're right. I mean, if I assume, in particular in this system here, that there is. If you, at the end of the lecture, I will show you our publication in which we consider this. If I assume that in any case, when the people is vaccinated cannot be infected, this is recovered.
If it's not relevant for the.
No, it's interesting question, but let me see. Now, of course, we can consider this. I think in this model, did you find so in Wikipedia this something like that? Without this, probably I don't remember how it is, but it is there. No, SIR. It's relevant because it's an advancement what you are what you are considering. I mean, here cannot be presented the susceptible, but the vaccinated.
Is it just plus UV because it's the same amount of people that are subtracted from the susceptible?
This could be, yeah. It seems to be reasonable, no? An interesting question, yeah. Think about it and tell me. Huh?
Okay.
Yeah, this makes sense. Plus UV. I would like to see in this sense, yeah. Yeah. Very good. Okay. Keep in mind this could be, I would like to say period plus UV. Really, we are interested at this moment at these two dynamics. We will see. Let me go ahead. 50 minutes. I have a 50 minutes to show you. And then next time, I hope to be here. Look at this. I will communicate. Yeah.
Just ask me, I have the same question. And it says that it's common that you add these vaccinated people to the last group of removed or recovered. So I guess it's common practice that you should add to the last group.
I would like to say yes, plus UV.
Yes.
we will see why I didn't ask him. First of all, because now we will see we are interested in the dynamics of S and I. But of course, it makes sense the question why would we consider the people who is vaccinating? Because we assume that they cannot be infected. This means they recover. Here is considered just the people died, the people is infected. Because if they infected, we assume that they immune. Makes sense. This also died. It's recovered in a sense. Don't care about it. No. Yeah, I think it plus UV. I would like to say reasonable to think. Look at this. I define, now we will introduce the controls. And using the control, we will define also the concept of the immunity, because the idea is to reach an immunity for the society. This now introduces a very important concept, control. Look, I try to define, in this sense, an absolute, so let me say, immunity. The immunity could be considered an ideal form, no infected. This is an ideal. If I don't have infected, problems in this sense. Of course, this concept of immunity is not applicable. We will see why. But in any case, we can define let me see, in the variable EI as the number of infected minus the number of desired infected. Seems to be strange, but let me say this difference between I and 0, if you want to consider this ideal situation, or I minus ID, undesired number of infected. Seems to be strange, but we will see. And the difference between what is and what I want. Ideally, I want 0. Could be. Basically, we don't define the immunity with respect to the infected. We define typically the immunity with respect to the susceptible people. And now we try to clarify why. SD, which is the difference between the susceptible people which I have today, which we will have over time, we will see this S over time, S of T, this means the number of susceptible people will change over time, minus SD, which is desired now, not infected, but the desired number of susceptible people. This is exactly the immunity. The reason is we cannot, I'm not expert, but I try to explain what the student will expect more than me. We cannot, it's easy to understand. Also for me, it was easy. We cannot vaccinate everybody. For instance, I was not vaccinated. But not ideological, because for physical reasons. In the family, everybody was vaccinated, but not me. It's a curious thing. Everybody was with COVID, me no. But this can be explained. Yeah. But I don't want to tell him. I can tell him, but I don't want to spend time. That is the truth, but not what this doesn't mean that it's not useful to him. Is my particular situation. But also it can be infected, but it was not the case. Look here, but we need to be vaccinated. Don't say that. But again, not everybody can be vaccinated. This means we define. Probably now I made some mistakes. No? 1 second, because it could be that from home they don't see. Yeah, I think, no? I don't know. It seems to be that something happens in the I don't understand what. Let me no. I hope that they can see from home. No? Now, we defined an SD relative low, but not zero. If SD is relative low, means that not all people can be vaccinated. This makes sense in the society. No? I told you about me for this reason. No? Look, now, second theorem of Lyapunov. Applied at this case here. The idea is to achieve with an UV, with a campaign of vaccination, SD, which must be defined, I don't know, in a society in Lüneburg, 1,000 people. Because not everybody can be vaccinated. I would like to achieve, to find UV. UV is characterized, I don't remember, the number of people vaccinated per day. I'll show you. Here is S is number of people per day, number of people per day. This must be, I don't know if you remember a little bit in gymnasium, no? This unit must be also reflected in the right part. This is number of people vaccinated per day. I can vaccinate per day, I don't know how many, but I have to calculate using my software, using my program, in order to say, please, tomorrow should be vaccinated this number of people, in accordance to the S0, the initial, the value of susceptible people of today, which I receive for the health office and so on, in accordance with the number of I infected people of today. This is the goal to realize in the software, to realize in the control. Control means to run the calculations and to tell to this healthy organization for tomorrow, please vaccinate this if you want to maintain our immunity. Defined somehow. They tell us how many people cannot be vaccinated. This can be calculated. I belong to this because the physician write for me in the letter that Paolo Mercalli cannot be vaccinated because the risk is more than the benefit. It is the truth. Okay. 5 minutes. I don't know, it could be interesting. If you are interested, we can also do 2 lectures, 2 supplementary lectures, next week and after next week. We can go ahead also with the project. Look at this. Lyapunov proposed another theorem, the second theorem of Lyapunov, in which he tried to define a positive function. We can see that I square, this S of t minus SD squared, centered at the point which I want to control the system. And a possible equilibrium point, but an equilibrium point which is not the equilibrium point of the system. Try to do at home where the system, for its internal structure, have an equilibrium point. This means put this equal 0 if I don't vaccinate. Look at home. Try at home. What happens if I don't vaccinate? This must be 0, this must be 0. Try to do at home. Of course, S equals 0, I equals 0, but there is another call. Could be interesting to find. But let me go ahead because I would like to tell you about this control. Nevertheless, even though it's a little bit ideal, let me consider the goal, as I told you before, infected 0 as a goal. Here, think about I minus 0 squared. This can be seen as I minus 0 squared. This means this expression reflects exactly an ideal, I mean, our goal in which we have I equals 0 is an ideal goal, infected 0. And S equals SD. So not all people can be vaccinated. Lyapunov says, if I am able, I try to tell you colloquially this theorem, without demonstration, if I am able to find UV, in our case, UV, an input. This means in our case, input is in the language of mathematicians, system theoretic people. This means how many people have to vaccinate per day to remain at I equals 0, not infected, and in the meantime, S equals SD. To obtain this UV equals 0, I have to calculate the derivative, basically the variation of this function, negative. This means as if, try to imagine, it doesn't matter where I am, s equal 1 million, in fact, 2 million, I will converge to 0 because the derivative negative in a positive function, think about a parabola, you know from gymnasium. The parabola, I will find a way to converge in my ideal equilibrium point, let me say, which is characterized in our case that s equal st and I equal 0. I think I don't want to go in depth on the calculation. We will see next week the calculation. Then in time, I give you an exercise. Try to calculate the equilibrium points. Next time, we will restart from here. I have just 10 minutes, the boring calculations. Basically, I have to calculate this. And then I will calculate u of v, an expression as a function of what? S, I, and the parameters, to have the value of people, which must be each day. Why each day? Because the model is S constant, remember? No people come in the society, but this means I have to restart each day with the number of people which are susceptible, the number of people is infected. But this is not a problem. You have time, you have all day, all night to produce the result for tomorrow. And then we will simulate with Matrix simulate. We will see how it changes. At all, try to put 0 here, 0 here, 0 here, because I would like to calculate if I don't vaccinate, what happens. This could be also interesting, no? We cannot answer with this relatively easy model, but there is complex models in which people, which is against the vaccination, not me. Believe me, ideologically, I'm not against. They try to see, please pay attention, mathematically, the virus will be weak alone. But anyway, don't care about this. No? But think about with this mathematical aspect, as we define the immunity, we can really try to understand a little bit better what happens to give some indication, at least with this system, how many people we will see next time must be or should be vaccinated in order to maintain my goal. Ideally, infected 0 and susceptible as less as small as possible. No? 0, 0 means here S equals 0 or I equals 0 or both. Here, in fact, S equals 0 and I equals 0 as in the rabbits, foxes, an equilibrium point. But not only. Look at them. There is another equilibrium point. There is another equilibrium point. I don't know if we can see from here. Huh? S, we will see also next time, equals A divided R. I will communicate, I hope to be here. If I'm not here, we will nevertheless, we do per Zoom. And then I hope to do another lecture because I see that you are interested in the topic. We can a little bit go ahead. But anyway, I will upload everything in my study and in YouTube if you cannot come. Don't think about S equal A divided R. It's an equilibrium point. I don't know if it's visible, no? Okay. I think we can conclude here. Thank you for your attention, questions, also for project and so on. I am here for any kind of questions.